welcome to Engineering Key Tutorials.
Good morning or good evening, wherever where you are.
Today's lecture is regarding to hydrostatic pressure. So this part of video considered as a theoretical explanation about hydrostatic pressure to give you the concept and the principle about hydrostatic pressure and different type of submerged surface such as vertical, which is a very basic one, and the inclined. Then we will go deeper and explain the curved surface, which is more advanced type of submerged surfaces in the fluids. Let's start with the definition of hydrostatic pressure. The hydrostatic pressure defined as the pressure exerted by the fluid at equilibrium at a given point within the fluid due to force of gravity or due to weight or specific weight of the fluid. And here we said equilibrium. Why we said equilibrium? Exactly why we said equilibrium? We said equilibrium because here we're talking about hydrostatic pressure. No external forces, no moving, so the fluid is stationary. So this is the reason why we said in equilibrium position. Let's imagine we have this tank or container contain this fluid, and let's take this imaginary cube of the fluid with height h, and we have the point A above this imaginary cube and point P below it. Again, because we're talking about equilibrium, summation forces acting on this imaginary cube equals 0. The force acting on the point A plus mg, which is the weight of the cube or the fluid cube, minus the force at the point P acting on the point P. Let's imagine it's in the opposite direction. We put it negative here, equals 0. Okay, we know the pressure equals force divided by area, so the force equals pressure times area. And we know also the rho equals, or the density of the fluid equals the mass divided by the volume, or mass of unit volume. So let's substitute with the value of the force by pressure times area. The pressure at point A times area plus rho g, which is rho g is the specific weight of the fluid, which is the weight of unit volume, times the volume of this imaginary cube of fluid, which is the area of this cross section times height h, minus pressure times area. So the area will cancel each other, and we will get pressure at point P minus pressure at point A equals rho gh. Because rho and g are constant, and here we have h, which is the depth of the fluid, so we can say the differential pressure between 2 points is proportional to the depth of the fluid. And this is the great conclusion. So guys, let's go deeper and take the advantage of studying hydrostatic pressure and studying submerged surfaces. In this subject, we have two major requirements. The first one is getting the value of resultant force due to hydrostatic pressure, and the second one is getting the position or acting point from this resultant force on these submerged surfaces. So let's talk about the resultant force due to hydrostatic pressure. To get the value of hydrostatic pressure, you have two methods. The first method is using the pressure prism, and the second one is using the equation of hydrostatic pressure, and you can find it in the previous lectures. I'm already put the link in the description below. You can find these general equations and the derivation of these equations and in the previous lectures that I put it in the description below. Let's talk about the pressure prism method. Let's imagine we have this fluid vessel or container with oblique wall AP. As I told you, the hydrostatic pressure is proportional to the depth of the fluid. So don't confuse yourself about inclined distance, inclined and vertical and anything. However, don't confuse yourself about it. We know the hydrostatic pressure is proportional to the depth or the vertical depth of the fluid. At point A, the pressure equals to the pressure at point C, which is equals to rho gh, h equals to pc. You deal with inclined pressure prism as any distributed load. The value at the base of this prism equals to rho gh as any vertical submerged surface. You can find the resultant force due to pressure prism equals to rho dh, which is the base value, times half, which is a conversion the prism to uniform pressure as any triangle load, times the area of submerged surface, which is the area in the perpendicular plane to the screen. To equalize this equation to the general equation in the second method, you can say half h equals yc, which is the inclined distance from the free surface to the centroid of the submerged surface, times sine theta. If you substitute with this value, you can find this pressure prism equation equals to the general equation in the second method. So the next one is how to calculate the center of pressure or the acting point of the hydrostatic pressure or resultant force due to hydrostatic pressure. You can calculate it using equation or general equation, or you can get it geometrically, and it depends on shape of submerged surface. And I also prefer to stick with equation or general equation, which is included moment of inertia of the submerged surface. Then let's talk about curved submerged surfaces. At the first, we want to get the resultant force acting on the curved submerged surface. Any resultant force or any force has two components perpendicular to each other. Let's take its component, horizontal component, which is x direction, which is in x direction, and the vertical component, which is in y direction, also which is in the direction of gravity or the weight of the fluid. To find the horizontal force Fh, we have to follow these steps. Step number one, you have to get the projection of the curved surface on vertical plane. Step number two, you have to calculate pressure prism on this vertical plane. Step number three, you have to get the horizontal force acting on the vertical plane as any vertical submerged surface. Then you have to find vertical force. It's easy, it's just the weight of the fluid above the submerged surface. The vertical force equals to V times gamma, which is a specific weight of the fluid, and V is the volume of the fluid above this curved surface. So the volume above curved surface, so V is the volume above curved surface to real free surface or imaginary free surface. And the next lecture we will solve lots of problems, and we will explain what's the difference between real free surface or imaginary free surface. And then it's easy to calculate the resultant force. It's equals to the square root of horizontal force squared plus vertical force squared. And see you later in next videos.